Good afternoon. Today we are going to discuss ray optics, and in the chapter we are going to discuss about the reflection and refraction. So first topic is reflection of the light. What is the reflection of the light? Or what is the reflection? Very simple. Say for example, this is the one kind of the media, this is another kind of the media. No need of always this is a whiteboard mirror. Yeah. So this is the one kind of the media, this is other kind of the media. Now, whenever the light will be incident on the boundary of the two different medias itself, actually partly it will be reflected, partly it will be what means refracted. The phenomena of reflection is nothing. The light which is just striking the what means boundary has to rebound back to the what means the first media itself only. Then that is simply called as the what means reflection of the light. If it is, for example, a purely plain mirror, then obviously almost 100% of the light will be reflected back. So the light, whenever it is incident on the boundary from one media, and again it will be rebounds back to the first media itself only, then that kind of the phenomenon is called as what means reflection of the light. So reflection of the light will be observed everywhere, anywhere, even presently also around us. As light falls on the different kind of the surfaces, it will be reflects back. So usually we are going to discuss here reflection of the light in the case of the what means mirrors only. So how many types of the mirrors are there? One is plain mirror is there, and other one is actually called as the curved mirror. I hope you are following. Plain mirrors and curved mirrors. Let us discuss about the what means plain mirror. Very simple. The surface from which the light is going to be reflected. That if that should be a plain surface. And of course, the plain mirror one side will be coated with the what means silver. So because of this coating, what happens means most of the light that will be incident on the plain mirror will be what reflects back. So that is simply can be called as what means reflection of the light itself. So in order to understand the reflection of the light and incident ray and reflected ray and so on like that, you have to understand one important thing is what is the normal. To understand the incident ray and reflected ray, wherever maybe the light will be incident, actually that is called as the point of incidence. At that point of incidence, you are required to draw a what means a normal. Now with respect to this normal, say this is the incident light. Now the angle made by the incident ray with the Normal is called as what means angle of incidence. And it will be rebounds back to the first media itself only. This is called as what means a reflected ray. And the angle made by this reflected ray with the normal is called as what means angle of reflection, small r. So what are the principles of this reflection of the light? Means very, very simple. The angle of incidence is equal to, you will get what means angle of reflection. Angle of phi is equal to angle of r. And incident ray, the reflected ray, and the normal all will be lying in the same plane. All will be lying in the same plane. So in order to understand the, or in order to know the how the reflected ray is actually going back, so you must know the drawing of the normal and mentioning the what means angle of incidence and angle of reflection also. Here, if you observe carefully, the actual path of the incident ray is how means like this. This is the actual path of the incident ray. But what happened? The ray is actually reflected in this direction itself. That means it is deviated from the path. By what angle actually it has been deviated? That is actually called as the angle of deviation. So from the figure itself, we can understand that from the geometry, as this is total 180 degrees itself, then angle of deviation is equal, you will get 180 minus I plus R. You know that I is equal to R. So you can write delta is equal to 180 minus either 2I or 180 minus 2R. This is the angle of deviation produced on the incident ray whenever it will be incident on the what means plane mirror. Suppose you say the light ray will be undergo the what means number of reflection or successful multiple reflections because of the number of plane mirrors itself. Then what is the total angle of deviation? That means like this. For example, this is the one plane mirror. This is the normal. This is the incident ray. This is the reflected ray. Again, you say, for example, this is another mirror. Say this is the normal. Now again, this is the another different angle of incidence. And again, it is reflected like this. Say, for example, now, like that, if the light successively reflects from the different plane mirrors itself, then what would be the total angle of deviations? Means simply have to write delta is equal to delta 1 plus delta 2 plus and so on like that. And it is better to understand that whether it is reflected clockwise direction or anti-clockwise direction. Here anti-clockwise, here clockwise. So accordingly, you have to take the angle of deviations also positive, negative, and so on like that. So this is the actually what we call this one means plane mirror. Reflection by the plane mirror. Just now we came to understand that when the light will be incident, it will be reflected. Angle of incidence is equal to angle of reflection. Just now we have discussed. And angle of deviation is equal to, we get delta is equal to 180 minus either 2I or 180 minus 2. That we can write. Okay, next. Formation of the image by the plane mirror. How the image will be formed. If you observe carefully, for example, if this is the plane mirror, say this is the normal, Say for example, I have placed a object like this. Then what happens? The ray which is going to be incident normally on the plane mirror, it will be obviously what happens means it reflects back. The ray actually which is incident at this center point, let me call as a pole. So symmetrically it will be reflected with the same angle. Angle of incidence is equal to angle of reflection. But there is no intersection of these two reflected rays in this direction. That means here you will not get any kind of the image. But if you observe carefully from here, you can feel that these two rays are coming inside the what means from the inside of the what in this plane mirror. That is, the image of this object will be appeared inside the what means plane mirror. This is actually a real object. Then this will become the what means virtual. What is a virtual image? The image which cannot be formed on the screen, which cannot be catch on the screen, that can be called as the what means virtual. It is only visible. So this is actually what means a virtual one, which is forming actually inside the plane mirror itself. Only it is visible. Very simple. If you look your image in the mirror itself, whatever we are seeing your image, that is actually what means virtual one. And from the geometry, one can easily say that the distance of the object, if it is u from the plane mirror itself, then the distance of the image inside also will get the what means same. That is equal to. So whatever may be the distance is from the object to the plane mirror, the same distance will be maintained inside the mirror also. That is, that image distance also will be same thing will be maintained. So like that, you have to construct the what means the image due to the what means this real object. So just now we came to understand that if it is a real object, you are going to get a virtual image. Is it possible to get the real image due to this plane mirror? Yes. For example, say from somewhere you are going to get the what means a converging beam of the light. That is, in the absence of this plane mirror itself, it is expected to get the what means image here. That is, this is the, let me take as a what means object. That means if there is no plane mirror here, somewhere because of the what means passing of these light rays through the different kind of the lenses or mirrors like that, final image that you are going to get what means at this point itself, that image as you're catching at one point itself, let me take as a what means object. But before forming that image, that is before we are treating it as an object, so we have placed what means here a plane mirror like that. Then definitely here image will not be formed because it is obstructed. Then because of that, what happens simply the light rays will be reflected back. That means this will become the what means final image. So what do you understand from this? Whenever the object is actually virtual, in the absence of this plane mirror, again I'm saying actually here the image will be formed because of the what means some kind of the processes. Now we have placed what means a plane mirror before forming this image. That means Whatever may be image that is going to be formed inside here, now it will be act as a what means object for this image. That means resultantly the image of the object which is going to be come from the outside will be formed here. That means whenever the taken object is virtual and the formed image will become a what means a real. That means plane mirror also will give the what means a real image whenever the object is a what means virtual. That we have to understand. And of course, this is a formation of the image by the plane mirror itself. So what transformation will be takes place easily you can understand when you look your image inside the what means mirror itself. If you raise your right hand, you feel that the object is the image of you is going to be raised over what hand means left hand. So lateral what we say displacement will be takes place. So P will be actually will be look like this. So this is the formation of the what means plane mirror, image by the what means plane mirror itself. This you have to understand. So left will be flipped to the what means right, right will be flipped to the what means left. So P letter will be flipped like this. So this thing will be happen because of the what means plane mirror itself. And of course, there is no change in the size of the object. The image is same as the what means object. But the only thing is this is the real one, this is the real one, this is the what means virtual one. The size is also same, size is also not changing. The distance, whatever may be, the object is maintained the distance from the plane mirror. That image also forming the what means, maintaining the what means same distance from the mirror itself. So except that flipping of the what means object image left to right or right to left. That only difference will be take place. So number of images formed by two inclined plane mirrors. Say for example, we have the combination of the two plane mirrors. Whenever we have the combination of the two plane mirrors, how many number of the what means images will be formed? I think this thing already have seen for example, museums or in some places in lifts, etc., like that. All the walls will be actually arranged with the what means plane mirrors itself. So because of arrangement of the different kind of the plane mirrors around us, we will get the multiple of reflections inside the what means mirrors itself. So how many number of the images will be formed? So that can be easily calculated with the formula. So for example, let me take like this. You can understand easily. Say this is the actually two plane mirrors are there like that, which are maintaining the what means an angle, how much means 90 degrees. And say for example here object is there. This is the object. So how many number of the images will be formed? So very simple. Due to the first mirror M1, say this is the second mirror M2. So already we discussed that if the distance is maintained, inside also you will get the what means one image. And similarly here also you will get the what means one image. But practically along with these two, you will get what means one more image here also. That means how many images you are going to get here means 3 images you are going to get. That can be easily understood by the equation that is equal to what means 360 by theta. Here angle between the two plane mirrors is equal to how much means theta is equal to 90 degrees. That is 360 by 90 means we'll get how much means 4 you are going to get. That means if you are going to get this value as what means even number, then the number of images formed will get as 4 minus 1 that is equal to 3. So these are the number of the images that you are going to get. Actually, this image is due to this mirror as well as due to this mirror itself. That means both images will be coincide, and hence finally only we will get the what means number of images is equal to 3. So for the first formula we have to use whenever the value of 360 by theta you will get what means even number. When you get 360 by theta value is equal to even number, then the number of images is equal to, you will get what means 360 by theta minus 1. That is equal to, you will get 3 here. For example, if you say 360 by theta is equal to odd number. If it is the odd number, then how many number of images will be formed? Then 360 by theta minus 1. Whenever the object is placed exactly at the what means angular bisector. Angular bisector means what? Say for example, these are the two plane mirrors. The angle between them is equal to what means theta. And this is actually called as the angular bisector. Now, if we calculate 360 by theta by known value of theta, then if you are going to get the odd number, and if object is present here at the angular bisector, then the number of images will be found. How much means 360 by theta minus 1. Just remember that formula. If object is not present at the angular bisector, then how many number of the images will be found? Means 360 by theta will be formed. That means instead of at this position, somewhere it is formed. Then inside, how many number of the images will be formed? 360 by theta, number of the images only will be formed. So these are the formulas we have to remember to calculate the number of images that are going to be formed inside the plane mirrors, two plane mirrors, which are actually inclined at an angle, how much means theta itself. You see, for example, if two plane mirrors are parallel to the each other, like this, opposite to the each other, and not this one. So let me take what is this. For example, two plane mirrors are placed opposite to the each other. If object is placed here, then how many number of the images will be formed? Infinite number of the images will be formed. Infinite number of images. Why? Because this image, this object image will be formed inside this one, and again this image will be acted as the object for this one, and so on, so on, so on, so on. Like that, infinite number of the what images will be formed whenever the two plane mirrors are parallel to the what means each other. So this is also very important. You must remember. Right. The concept of velocity of the image in the plane mirror. So far, we have discussed that whenever the object is placed at certain distance from the plane mirror itself, the image also will be formed inside the plane mirror at certain distance, same distance. What happens if the object is moving? How the velocity of the image will be changes? That we have to discuss. This is the object. Say this is the what means distance u, and image distance also you are going to get what means e inside. Now one can easily understand whenever the object is moving towards the mirror, the image also will be moves towards the mirror, that is towards you or towards the object. That is, distance of the image with respect to the mirror is equal to nothing but minus of distance of the object with respect to the mirror. But because we have to find out the what means all the distances from the center point only. So all these distances should be taken as the what means negative values. From here, all the distances should be taken as the what means positive values itself. So SIM, that is equal to minus SPM. Distance of the image with respect to the mirror is equal to minus of distance of the object with respect to the what means mirror. Now, as the object is moving, that means there is a change in the what means position of the what object, as well as there is a change in the position of the what means image. Object image changes and image position also will be changes. So when you differentiate this one, velocity of the object, velocity of the image with respect to the mirror is equal to nothing but minus of velocity of the object with respect to the mirror. If you want, you can take the what means vector representation. No problem at all. VIM is equal to minus VOM. You see, these are not actually absolute velocities. This is the velocity of the image with respect to the mirror. This is the velocity of the object with respect to the what means mirror itself. So reference to the mirror only, we are saying that if one object is approaching towards the mirror, approaching the mirror means image also approaches the what means mirror. That means both will be approaches means both velocities are actually acting in the opposite directions. Now, how this equation I am going to change? Look carefully. VIM, what I can write? Velocity of the image minus velocity of the mirror. You know the relative velocity concept. Velocity of A with respect to B is equal to nothing but velocity of A minus velocity of B. This is actually called as the what means relative velocity concept. So VI minus VM is equal to what I can write? Minus of what I can write? VO minus VM. So from this what I can write? Velocity of the image how I am writing this one, look carefully. Velocity of the image with respect to the ground. Say I am observing this whole thing outside. From here I am observing. So velocity of the image with respect to the ground minus velocity of the mirror with respect to the ground is equal to. Here I maintained the speed of the mirror is equal to 0. If mirror is also moving either towards the object or away from the object, then the scenario will be changes. The velocity of the image will be changes with respect to the object or with respect to the mirror and so on like that. So let me consider the velocity of the mirror also with respect to the ground. Then here what should I write? Velocity of the object with respect to the ground minus velocity of the mirror with respect to the what means ground. So what formula you are going to get here? So velocity of the image with respect to the ground is equal to you will get. So when you take this side, minus into minus plus is a VMG and this come this side 2 VMG minus VOG. This formula is very useful for finding the what means velocity of the image with respect to the what means ground. This is a pure velocity. With respect to the ground means reference frame, ground is taken as a reference frame. So ground is actually at the rest itself. So with respect to us, if object as well as the mirror also moving, how we are going to get the image velocity? That easily can calculate with the help of this equation itself. So this formula will be used for finding the what means velocity of the image whenever the velocity of the mirror is also given. If you have any doubt, you check here also. If velocity of the mirror is equal to 0, what happens? You tell me. Now simply velocity of the image with respect to the ground is equal to minus of velocity of the object with respect to the ground. That only we discussed now. If object is approaching the mirror, Then for a person who is outside, he also feels that the image also approaching with the same velocity itself. Simply the direction is what means opposite. So this is very, very important equation. So you have to remember this one. Sir, what happens, sir, if the object is not only moves toward the what means this plane mirror, but also if it is moving what means parallel to the plane mirror like that. Let us check that one. See, for example, this is the plane mirror. Now, this is the object. Now it is moving like this. One can easily understand. This is also image. It is also moves with the same velocity in the same direction. So for the motion of the object perpendicular to the surface of the what means plane mirror, you are getting the what means velocity in the opposite direction. But when you take the velocity component parallel to the what means surface of the plane mirror, there is no change at all. There is no change at all. That is velocity of the image with respect to the mirror parallel to the surface is equal to velocity of the object with respect to the mirror parallelly. So this is very, very important. Now let us check out a small problem here. For example, here object is there. For example, say it is approaching plane mirror with a speed of how much means 2 meters per second. Then what is the velocity of the image? First question. Very simple. Velocity of the image with respect to the mirror is equal to minus velocity of the object with respect to the mirror. So that is you will get 2 meters per second. This you already know. If I ask you what is the velocity of the image with respect to the object, then how to find out? What I asked? Velocity of the image with respect to the object. So what should I write? Vi minus V. So that is Vi with respect to mirror minus Vo with respect to mirror. So how much we got Va with respect to mirror? Minus 2 meter per second. You forget about later we will discuss. No. VOM is equal to how much? That is 2 meter per second only. 2 meter per second. That is how much we get? Minus 4 meter per second. You see, velocity of the image with respect to the object. Velocity of the image with respect to the object. That means for this person, when he is moving with a speed of 2 meters per second toward the plane mirror, he feels that the image is actually approaching with a speed of how much means 4 meters per second. So simple, that relative velocity concept formula you have to write. From that easily we can understand. So this is the one of the good examples with respect to something how to find out. For example, here we have an object is approaching a fixed plane mirror with a velocity 5 meters per second, making an angle of 45 degrees with the normal. The speed of the image with respect to the mirror is equal to how much? This is the question. So how to solve this one? So this is the plane mirror you have. Say this is a normal. Say here object is there. Now object is moving toward the fixed plane mirror with a velocity of 5 meters per second, but making an angle 45 degrees. That is, this is the 5 meters per second. This is the angle 45 degrees. Then what is asking? What is the speed of the image with respect to the mirror? Very simple. We already know that velocity of the image with respect to the mirror is equal to nothing but minus of velocity of the object with respect to the mirror. Obviously, we'll get 5 meters per second only. You don't get any change in this. But we'll try to understand whether we get the same thing or not by going through the concepts which we discussed previously. No doubt it should be 5 meters per second only. Now, you see here, the velocity can be resolved into the two components. One is 5 cos 45 means we'll get 5 root 2 meter per second, which velocity component is approaching the plane mirror normally. And where is this one? It is also, you will get what means 5 sin 45 means 5 by root 2 meter per second. So these are the two components we got. Now clearly we already discussed that the component which is normal to the plane mirror, the velocity component which is normal to the plane mirror, you will get the same magnitude but in the opposite direction. That's all we discussed. But the component which is parallel to the what means velocity component which is parallel to the plane mirror, without any change in the magnitude and direction, you will get in the same. So if I take the, for example, image here, so this image velocity is equal to, you will get 5 by root 2 meter per second, and this is 5 by root 2 meter per second. So ultimately, you will get resultant velocity is equal to 5 meter per second only. So then what actually happened here means the component, velocity component, which is normal to the plane mirror itself, that direction only just reversed without changing the magnitude. But because of that one, the total magnitude of the image is not changed. 5 meter per second only you will get. That magnitude only you will get 5 meter per second. Minus sign only indicates the what means the direction. That means ultimately you will get the plane mirror in the image also you will get in the same direction itself. Here I only wrote the what means magnitude. So this is the a simple problem you require to understand. You see one problem. Here a bullet of mass m2 is fired from a gun of mass m1 with a horizontal velocity v. A plane mirror is fixed at a gun facing towards the bullet. What is the velocity of the image of the bullet formed by the plane mirror with respect to the bullet? So finally, what is asking? Is asking what is the velocity of the image of the bullet with respect to the bullet? That's all. So we require to find out what velocity of the image with respect to the mirror minus velocity of the bullet with respect to the mirror, or velocity of the image with respect to the ground, velocity of the bullet with respect to the what means ground. This value, either this one or this one, we have to find out. Then how to do this problem? So this is the plane mirror we have. And somewhere you have the what means gun. Mass of the bullet is given to you m2, and the velocity is given to you what means v. Mass of the gun is equal to given to you m. The only thing here is the plane mirror is fixed at the gun. That means these two are fixed. So because of fixing, what happens? From the law of conservation of linear momentum, when the bullet is fired from the gun, as the bullet moves in the forward direction, gun will move in the backward direction. So with what velocity gun will move in the backward direction? That you can easily find out with the conservation of linear momentum. So bullet mass is m2, velocity v is equal to m1 into say v dash. So v dash, velocity of the gun is equal to nothing but you will get m2 by m1 into v. Of course, you will get in the opposite direction. No doubt at all. To conserve the momentum, v dash is equal to minus m2 by m1 into v. What is this? This is the recoil velocity of the workpiece. What is the equivalent of this velocity? Well, because this is fixed to the workpiece plane mirror. Because of that, what happens when the bullet is fired? Along with the gun, the mirror also will move along with the workpiece gun. That means as the bullet is approaching, the mirror also will be approaches with what speed means m2v by m1. So in the previous cases, we assumed that velocity of the mirror is equal to 0. But this time velocity of the mirror is not 0. You are going to get certain velocity m2v by m1. However, I represented the here direction. You can neglect the minus sign. However, in writing the what we say formula, we will write minus. No problem at all. Now, what is my intention to find out? Our intention is to find out velocity of the image with respect to the bullet. So let us find out the true velocity of the what means image. So to find out the true velocity of the image, already we derived one equation. What is that one? Yeah. Velocity of the image with respect to the ground is equal to 2vmg minus vog. Let us use that one. So what we got that? Velocity of the mirror with respect to g minus vog, isn't it? That only we wrote now. Let us check it again. 2vmg minus vog. So, velocity of the image. Let us find out with respect to the ground. With respect to the ground, velocity of the mirror, it is in the backward direction. So you know that 2 into minus of m2v by m1 minus velocity of the object with respect to the ground, nothing but bullet. Bullet is approaching with velocity v only. So what do you get here finally? So you will get v common. So you will get minus of m2 by m1 plus 1 into v. This is the velocity of the image with respect to the what means the ground. Yeah, no mathematical problem here. Okay. So what actually we require to find out velocity of the image with respect to the what means bullet. That means what should I write? Vi minus Vb. Vi is equal to with respect to the ground, how much we got? That is minus of m2 by m1 plus 1 into v minus velocity of the bullet with respect to the ground means same direction, that is equal to. So ultimately, what you will get after simplification, if I take what means v common minus of, so what I get here, m2 by m1 plus 1, and again you will get what means plus 1 That is what you get, and V will be there. So minus of, you will get 2m1 plus m2 by m1 into. This is the velocity of the image with respect to the what means bullet. That means for bullet, which is traveling with a speed of v, that means when you sit on the bullet, you feel that the image is approaching with what velocity means 2m1 plus m2 by m1 into v. So this is very beautiful problem. Nothing is there, whatever we discussed, and by using the relative velocity concept, we derive everything here. I hope you can follow this. Let us go to the next problem. So here given that two plane mirrors are arranged as shown in the figure. Area has been incident on mirror M1 at an angle of 40 degrees. Find the deviation produced in after 3 reflections. So we already know whenever the light ray will be incident on the plane mirror, it produces the deviation of delta is equal to how much means 180 minus 2i. Now here two plane mirrors are there, and he is asking what is the total deviation after 3 reflections that we have to find out. So let me redraw this again. Plane mirrors. Yes, this angle is given to you 20 degrees. This is M1 mirror, this is M2 mirror. Now this is actually normal you have. Now this is the light ray which is incident at an angle how much means 40 degrees. Now after 40 degrees, after in point of incidence, after incidenting on the plane mirror M1, it will be what means reflects. And of course, this angle also you will get how much means 40 degrees. Now, with what angle of incidence it will be incident here? To find out that one, you check carefully. One thing, I will take this. Yeah, it is given 20 degrees. Now this is M1, this is M2. Here it is incident at an angle of how much means 40 degrees. Now it will be a reflex like this. This angle also will become how much means 40 degrees. Then how much this angle will become? This total is equal to 90 degrees, isn't it? So 90 minus 40 means this angle is equal to greater or 50 degrees. This is forming a what means a triangle. 50 plus 20, 70 degrees are there. Then along with the surface, this angle must be is equal to how many degrees you should get? 110 degrees. 110 degrees means you should draw a normal here. Now it will make an angle how much means? Tell me, as this is normal 90 degrees, this rest of the angle will become how much means 20 degrees. That means on the second mirror M2, the reflected ray from the first plane mirror is going to be incident with an angle of incidence 20 degrees. And again it will be reflects with the angle of incidence is equal to 20 degrees. Then how much angle it will become? If you check it again, look carefully. This is the total is 110. This is 20. This is 20. 20 plus 20 is equal to how much? 40. 110 minus 40 means we will get how much? Means 70. When in this triangle, this is equal to 70. 70 plus 20 is equal to 90. And remaining angle is equal to, we will get how much? Means 90 degrees. So for first reflection, it is going toward the plane mirror EM2 with an angle of incidence is equal to 20 degrees. After second reflection, it is going to be incident again normally on the what means first plane mirror. Then again it will be rebounds back, and again it will be comes back, and it will be retraces the what means its path. Now the question is, what is the angle of deviation? So let us find out the angle of deviation. Delta 1. In the first case, how much you are getting? 180 minus 2y. 180 minus 2 into 40. That is equal to 80. That is equal to how much? Means 100 degrees. Now it is reflecting like this. So clockwise. Now delta 2. Again 180 minus 2y. 180 minus 2i. 2i means how much? I is equal to 20 degrees there. That is equal to 40. 180 minus 40 means we'll get how much? Means 140. This you are getting anti-clockwise. Well, delta 3. Delta 3 is equal to how much you are going to get? It is going to be incident normally. So again it is that is delta 3 is equal to, you will get how much? Means 0. It is going to be incident and it is going to be coming back. Or 180 degrees also we can say. 180 degrees. It is traced back now 180 degrees. Now what is the total angle of deviation? And of course this is clockwise, and this also can be taken as a what means clockwise. Now you take it all the clockwise as positive and anti-clockwise as negative. Then finally you will get the what means answer. So let me tell these two problems and I will leave the session. Two problems only. For example, here, two plane mirrors are arranged at right angles to each other as shown in the figure. A ray of light is incident on the horizontal mirror at an angle theta. For what value of theta does the ray emerges parallel to the incoming ray after reflection from the vertical mirror itself? That means for what should be the angle? Theta is equal to how much? After second reflection, that has to become parallel to the incoming ray. That means it has to come like this parallel. Okay. Say for example, the angle of incidence is equal to here theta. Then it will be reflects now. It will be reflects. So this angle is also obviously theta. So what is the deviation actually produced? We will get 180 minus 2 theta. Then here how much angle of incidence will take place? This one. This is already 90 degrees. This is 90 minus theta. Then this will get how much? Means theta. This will get how much means 90 minus theta. And again it will be reflex. That is equal to, you will get how much means 90 minus theta. That means, first of all, it is going to be deviate in the clockwise direction. And here also it is going to be take place clockwise direction. So it has to return come back. That is in this backward direction. Parallelly, it has to be come back. So the deviations must be produced. Should be independent of the what means theta. So let us calculate that one. What should be the angle of deviation here? Delta is equal to 180 minus 2 theta. What is the angle of deviation here? Angle of deviation is equal to 180 minus 2 into 90 minus theta. How much you get? 180 minus 180 plus. This is, I think, something wrongly I have written. One 180 minus 2 into theta is equal to how much? 90 minus theta. That is how much you are going to get. 180 minus 180 plus 2 theta. That is 180, 180 you are going to get cancelled. Then delta 1, delta 2. So what is the total angle of deviation if you find out? Delta is equal to delta 1 plus delta 2. That is 180 minus 2 theta plus 2 theta. That is how much deviation you are going to get? 180 degrees. You see? Whatever may be the light ray will be incident here, irrespective of the angle of incidence, it is undergoing the what means? Angle of deviation is equal to 180 degrees means it is perfectly coming parallelly in the backward direction. So he is asking what should be the value of theta to get the parallel beam of the light after its incidence on the what means second mirror itself. So it is independent, irrespective of the theta, whether it is 10 degrees, 20 degrees, 30 degrees, or 15 degrees. So with whatever may be angle of incidence that will be incident here. So it will be reflects from the second plane mirror parallelly in the backward direction itself. So this is the question that we have to understand. So let me tell this problem finally. Here plane mirror is given to you at the origin parallel to the what means y-axis, facing the positive x-axis. An object starts from the 2 meter 0, 0 with a velocity 2i plus 2j meter per second. The relative velocity of the image with respect to the object is equal to how much? Now this is the mirror. Plane mirror is based at the origin. So this is the origin. Say parallel to the y-axis. Say for example, this is the plane of the what means plane mirror parallel to the what means y-axis. This is the x-axis, this is the y-axis, and out to the board you will get what means z-axis. To represent the plane, I have given this one, but no problem, you can understand like this. This is the plane mirror along the y-axis. This is the origin, this is the positive x-axis, this is equal to negative x-axis, this is positive y-axis, this is negative y-axis. Out to the board, positive z-axis, into the board, negative z-axis. Now an object starts from the 2 meter, 0, 0. X quadrant is actually given to you 2 meter, 0, 0. You see 2 meter, 0, 0 means somewhere actually here you have to get. So you have to flip this one. But don't worry, you take here, for example, 2 meter, 0, 0. But because object cannot be inside the plane mirror itself. So you can flip this one. Flip the mirror itself. Next, what is asking? The relative velocity of the image with respect to the object is equal to how much? You see, the velocity of the object is 2i plus 2j, that is along the x-axis is 2i meter per second, along the y-axis is equal to how much means 2j meter per second. The relative velocity of the image with respect to the object, that is vi with respect to object, vi that we have to find out. So we know already what is the velocity of the image. You will get like this. This is minus 2i meter per second. This is 2j meter per second. That is velocity of the image with respect to the mirror is equal to, you will get minus 2i plus 2j meter per second. Now what is asking actually velocity of the image with respect to the object. That is vi O is equal to vi minus vo. You know already vi, that is equal to how much? Minus 2i plus 2j minus vo is equal to how much? 2i minus 2j. So minus 2j plus 2j gets cancelled. You will get minus 4i meter per second, 4i. That is ultimately the velocity of the image with respect to the object. You will get what means minus 4i. That is along the negative x-axis actually you will get. So this is the one of the important problems. So this is the mixture of the what means vector concept as well as the what means this ray optics reflection concept itself. So when you have all these concepts with you, then easily you can solve the problems. So that's all for today. And in the next class, we'll discuss about the reflection by the what means curved surfaces, such as convex mirror and concave mirror. And then next we go through the what means refraction also. Thank you.